last meeting, we started solving number 2. So to review, we have 2 blocks. And the question is, we want to compute the magnitude and direction of the friction force. Now, first of all, we needed to know which direction is it moving. So we already found out it's to the left, right? Now, the next step is to know, is it actually moving? Okay, so let's check. So check if stationary. Or check if moving. Okay, so for block for block A, that's easy because there's only force and then a surface that's considered. So this system on its own is a typical example for friction. And to solve if it's moving or not, we're going to solve for its phi and theta. Okay, so for block A, we're checking theta and phi. Recall, equation for phi is just arctangent mu. Mu being your coefficient of static friction, and that is 0.3 for block A. Solving for this, we get 16.70. Okay, and then we need to compare that to theta, which is given. And we have the slopes of your theta, and then to get this angle, you just use tangent again. Opposite over adjacent. Opposite is 3, adjacent is 4. So arctangent, opposite 3 over 4, we get 36.87. And then from this, you'll see that theta is greater than phi. And then from our lecture, when theta is greater than phi, it's moving. So now we've checked for block A is indeed moving. Okay. Therefore, sliding down. Now we need to check, is the force generated by block A enough to overcome the friction in block B? Now the solution for this isn't as simple as block A. We need to check the tension forces. If twice tension A, since again, this is our basis for equation, twice tension A is greater than tension B, then yes, block A overcomes that friction. So now let's solve for your tension values. Okay, so let's start with block A because that's easier. But now we're gonna solve with friction. Okay, because again, we're checking if our tension or force overcomes that friction. Okay, so I'm just gonna copy this since the free body diagram is generally the same, right? The only difference is there's now friction. Also, I'm gonna rotate this. Okay. All right. And again, we have friction here. Okay. So once again, this free body diagram is the same for here, except there's friction. Again, this is to the left, so the moment or the motion of this to the left, friction is always opposite that. So friction would be this way. Okay, that's your FA. So this is your FA. So here, that will be this way. Okay, and now use equilibrium equations to solve. So let's start with summation of forces y, so that we can solve for normal force since friction is mu n. Okay, so NA minus 3,000 vertical component, so that's 4/5. Way to 0, and then solving for this, you get 2,400. Right? And then, again, the goal is solving for tension. Let's move on to summation of forces x. Fa to the right, so positive Fa minus 3,000 horizontal component, so horizontal side is 3 over hypotenuse 5, and then plus Ta equals 0. Fa is mu n, so that's 0.3 Na, and that's this value. I'm not going to write that anymore. And then minus 3,000 times 3/5 plus Ta equals 0. And then you can solve for Ta. Ta is 1,080. Next, going on to block B. And once again, draw your free body diagram. I'm just going to copy that. Okay. Again, I'm going to rotate. If you don't want to rotate, that's fine. You should get the same answer. Okay, and then again, the only difference is there's friction. The movement of this is upward, right? Therefore, friction is opposite of that. That's going to be downward. So this is your FB. So FB is downward. So that's over here, right? So therefore, here we have this. This is your FB. And once again, use your equilibrium equations. So let's start with X. Again, to solve for the normal force. Summation of forces X equals 0. Negative 2,000 horizontal side, so that's 3 times 3/5 plus NB equals 0, and then NB is just 1,200. And then move on to Fy to solve for tension at block B. Okay, so TB negative 2,000 4/5 minus FB equals 0. And once again, FB is just mu n. So 0.3 times NB equals 0. From this, you can solve for TB. And TB is 2,080. And then again, you're going to use this pulley to compare tension at A and tension at B. Okay. So like what we did here, we're comparing twice TA. Twice TA is 2,000 plus, and that's obviously greater than TB. Twice TA greater than TB, therefore moving. And now all we know is that it's moving, right? So that means the coefficient of friction that we'll use is actually your mu k, not mu s. Okay, so everything we've done so far is just for checking. Now let's move on to the actual solution. Okay. So it's moving. So the equation here is F equals mu kn, right? So to be more specific, again, let's start with block A, mu kn. Mu k for block A is 0.20. But what about N? What's NA? It's still this. Okay, why? Because whether it's moving or not, this is still the value of 2000 of your normal force because it's not dependent on your friction. As you can see in our equation, it doesn't include friction. That's the reason why I rotated my axis so that the axis of friction will cancel out. Okay, so that means N is also 2,400. Please solve. What's the answer? Correct, Ricky and Rafael. Sorry. Or 80. So that's our first answer. And then FB, also mu kn. For block B, mu k is 0.30. And then N, again, it's the same because it's independent of your friction. So that's 1,200. So in short, to solve for normal force for the final equation for friction, you're just going to use your free body diagram with friction and then solve for normal force as usual. So please solve what's FB. Correct? Kurt and Marilyn. So the La Cruz purposes. Right. 360. Let's double check direction and friction, magnitude. So to get direction, again, everything's to the left, right? So this is the direction of our friction. So FA is like this. FB is like this. Okay, so that's number 2. Bit of a long solution. Any questions for number 2? Please answer in the chat. Okay. Now again, in the event that this is simpler, meaning our setup is just like this. Okay. So the only difference now is instead of comparing twice TA, that's just TA and TB. Okay. So for a simple system for pulleys, again, it's just TA and TB, not twice TA and TB. Right? Okay. So since you don't have any questions, let's move on to the next problem. Number 4. The 10 kilonewton cylinder shown in the figure is held at rest on a 30-degree incline by a weight P suspended from a cord wrapped around the cylinder. So you have this incline, you have your cylinder, and then there's weight hanging that was wrapped around it, keeping this in equilibrium, meaning it's not moving. If slipping impends, determine P and the coefficient of friction. So we're looking for two things, again, P and mu. It's impending, therefore there's no movement, so that's static component of friction, or component of static friction. So let's solve. First, create your free body diagram. Okay. So you can use this as is, okay, that's fine, or you can just use a separate free body diagram. So let's try starting here, okay? So I have a weight P. This is what we want to look for. Now notice the way that it is drawn. It's not acting directly at the center, or it's not obvious that it's directing at the center. Okay? Meaning, we have a non-concurrent force system. So meaning, whenever we have a non-concurrent force system, we usually use the concept of moment. So now how do you use that? So to use that, I need to choose a moment center. Okay. And for a system like this, there's two choices. One is at the center of your cylinder, and the other is at the point of contact. So let's try at the point of contact, right? So let's just specify what's happening, right? So this has weight. Weight is always at the center. So there's a downward force here. That is 10 kilonewton. Now let's say I want to take our moment center at this point, right? I would need the distance of P to this point. So let's solve for that. Okay. So again, this is what I need. Now what if I do this? If I draw a straight line from the center to your string holding your weight, this is actually the radius of your circle as well. And we're given diameter. Our diameter is 20. Therefore, this whole thing is 10, right? And what I need is this perpendicular distance to this point. So let's call that x. Okay. Now, aside from that, if I draw another straight line here, we have a right triangle. Okay. And then this right triangle, as long as I know one of its angles, I'm able to use your trig functions to solve for one of its sides. Now, if I manage to solve for this side, right, I can solve for x, and that's just 10 minus whatever the value of this is. So let's start with that. I'm going to isolate that drawing. Okay. So this length is just total length 10 minus our variable x. So this is 10 minus x. Now what else can we solve for? We have an angle here, 30. Now how can I transfer that here, right? Well, this point to this point is again your radius, okay? And then this slope is also tangential to your cylinder or circle. Now take note, cylinder slopes and a cylinder are always tangential. And remember what we mean by tangential, right? That means this line and this line are right angles. Okay, now that we know these are right angles, and then if I extend this, these are also right angles, we can use the concept of perpendicular angles to solve for one of these unknowns. So how? Okay. So let's choose a different one. That's correct, Rafaela, but I'll show you how. So this side perpendicular to this side perpendicular to this side, angle between them is also equal. So this is 30, this is also 30. Okay, that's it. So this is 30, this is 90. Therefore, 180 minus 90 minus 30, that's 60. Okay. And then from that, we can solve for x using, again, trig function, specifically cosine. Cosine 60 equals adjacent, which is 10 minus x, over hypotenuse. Now, what is that hypotenuse? It's this, which is, again, the radius of your circle, and the radius is 10. So from this, you can solve for x. What's x? Correct, Ricky and Lauren, it's 5. Very true. Okay, yeah. 5. Okay, now I know the perpendicular distance. I can move on with solving for moment. Okay, so summation of moment. Let's call this point A. Okay. Summation of moment at A equals 0, right? Weight is always downward, so downward rotate about A, that's counterclockwise. So negative P, again perpendicular distance is X. What other force is there? We have this external force, rotate about A, that's clockwise, so plus 10. Perpendicular distance is this, right? And that's just 10 minus X. There's no other external force. Remember, whenever we're creating free body diagrams of the entire system, we're only including external forces and reactions at support. Technically, there's no support here, so there's no reaction to solve for. So just equate to 0. So please solve what's P. Correct, Lloyd and Nicholas. Sosa and Glenn. It's 10. Okay, now we have an answer. Next is, what are we solving for again? Coefficient of friction. So that includes knowing what friction is. Right. So one way to solve for this is to use moment again, but instead moment about this point. Okay. And then now you're gonna include your reactions. Okay. So there's N here. This is impending motion. Even though it's impending motion, friction is still present. Tendency of the cylinders move here. So this is your friction. And now you can use summation of moment about this point at the center, and then from that, you can solve for friction F, because N passes through the center as well. Or if you don't want to do that, you can just use your equilibrium equation, summation of forces vertical and horizontal. So let's draw. This is your center. Right, again, weight always downward. That's W or just 10. Next, what else? We have N. N. What else? We have F. Now, what about this P? Now, if you recall our past topics for resultant, whenever you have a pulley, right, and there's pulley, and then there's tangential forces. Remember, the location of the resultant of those forces would be at the center of your pulley. Okay? And that means any force tangential to your pulley or cylinder will also act at its center. So that means we can analyze it this way. P is also acting at the center. Okay? So I'll place that here. Another downward force P, or we can just put it here. P. Okay, next figure out our angles. What is this N? Now we already know, right? Angle of N from the horizontal is just a complement of the theta, angle of your incline. Complementary of that, that's just 90 minus 30, so this is 60. Okay, that has the same slope or same incline as your surface, so this is 30. And that is your free body diagram. And then from this, you can create your equations. Let's start with summation of forces X. Now you can solve it as is, right? Summation of forces x and y, you'll have two equations and two unknowns. Then you can solve simultaneously, or again, you can just rotate your axis. So instead of rotating, I'll just do this, okay? I'll just note, this is my x-axis, this is my y-axis, okay? So summation of forces x equals 0. So along this axis, so we have n to the right, so just positive n. What else? P. Okay, now how do we do that? So let's do this. Again, this is our axis x now. So I need angles from that axis. So this is what I need. Now how do we get that? Now remember, to get n on the x-axis, you're going to rotate 60 degrees clockwise, okay? So again, rotating, it turns into this. This is your n, it's going to turn here, and that is 60 degrees clockwise, okay? So everything moves 60 degrees clockwise. So therefore, this also moves 60 degrees clockwise, okay? Therefore, this angle is just 90 minus 60. So this is 30, okay? So I urge you to practice doing all of these things so that it's less confusing, okay? And then looking here, again, this is your x-axis. 10 is to the left, so negative 10 cosine 30 for horizontal component. P has the same location as your weight 10 or has the same orientation, right? So I can just extend P here, and you'll see that it's also to the left, so negative P cosine 30 as well. Negative P cosine 30. And P is 10. From this, please solve what's N. Correct. Correct. Lauren and GM. Gustos, sure. $17.32. Okay. Next, store that in your calculator. And then next, move on to summation of forces y. Okay. So this is now your y. So F is upward, so positive F. What else? We have this downward. They're both downward. So negative 10. Vertical component is sine. So that's just 10. Sine 30, as well as P. Negative P. Sine 30. There's no other force equate to 0. Please solve what's F. Correct. F is 10. Correct, Naomi and Jose. Legado and Minoso. Positive 10. 10. No need to store that. Now again, the goal is what? Coefficient of friction. Now recall one of our equations, right? We have this. F equals mu n. I already know F and n. I can use that to solve for mu. Okay? So mu is just equal to F over n. We already know both values, so please solve what's mu. Correct? Gian and Zaira. Sort this. So 0.58 if we're rounding off to 2 decimal places. Okay, so that's our answer. That's number 4. Any questions for number 4? Please answer in the chat. Okay, if you don't have any questions, let's move on to number 5. Mm-hmm. Oh, 4. This is 3. Then this is 4. Okay. A ladder 6 meters long has a mass of 18 kilograms and its center of gravity is 2.4 meters from the bottom. The ladder is placed against a vertical wall so that it makes an angle of 60 degrees with the ground. How far up the ladder can a 72-kilogram man climb before the ladder is on the verge of slipping? So again, that means impending motion. The angle of friction at all contact surfaces is 15 degrees. So basically, we're just looking for location of your man, of your person, before your ladder starts slipping. So first step is to try to draw what's happening. So we have a ladder, right? 6 meters long. So this is 6 meters. Yeah. And then we have location of forces. 18 at 2.4 meters from the bottom. So here, somewhere here, this is the weight of your ladder, and that's 18 kilograms. And then here. So 2.4. Right? Next, you also have your man. Okay. And the man is 72 kilograms. So let's say here, okay, this is 72 kg. And this is what we're looking for. All that X. Then again, the total length of this ladder is 6 meters. Okay, what else is given? You also have 60-degree incline, and then phi is 15. So this is 60 degrees, and then phi 15. Okay, so how do we solve? Well, first, okay, we're gonna figure out your reaction forces. So here we have objects in contact. And remember, whenever you have objects in contact, there's friction and normal force. Normal force parallel to the surface. And then let's call this point A. Okay, so this is NA. And then friction force, right? So if you have weight here, the tendency of this ladder is to move this way, right? downwards and to the left. Again, friction always opposes that, so friction would be to the right. FA. And then same thing here. Let's call this point B. Right? Again, normal, perpendicular to your surface. The tendency of your ladder is to go downward, so friction is upward. So FB. Okay. Now that we have that, the goal is to solve for X. One of the ways to do that is, if I know FB and NB, I can take moment about point A to get this value of X, right? Because the distance of this 72 kilogram force, or at least a component of that, has a distance X from point A. Okay? So in order to do that, again, I need to solve for these two first. Okay? So before doing that, what can we do? This is a non-concurrent force system, meaning we can't do what we've been doing earlier, which is to create your concurrent force system free body diagram. However, even though it's a non-concurrent force system, equilibrium equations still apply, meaning summation of forces X and Y equals 0 are still applicable. So we can use that. Let's start with summation of forces Y in order to get an equation. So let's start here, and NA upward, 18 and 72 downward, so minus 18, minus 72. Now you might be wondering, why am I not converting this into weight? This is just mass. Not because it doesn't matter, okay? We're not particular with the unit of our forces here, okay? Because all of our units, as long as our units are uniform, we can use it without converting it. So they're both kilograms. So that means all of our forces, when we answer, it will also be in kilograms. Okay, that's the only thing that will happen. Okay, so 18 minus 72, and then we have FB upward. So plus FB equate to 0. Next, let's simplify. Create an equation. NA plus FB, 18 and 72 equates to 90. Then transpose to the right equals 90. And then we have our first equation. Next, to get our second equation, you're going to use summation of forces X. Let me further rewrite this, because again, F, if you know, is mu N. So we can write this as NA. Again, friction is mu N. So mu NB equals 90. So that all of our variables are in terms of normal force. Okay, again, that's our equation 1. Next, summation of forces Y, X, for the other equation. Okay. So we have FA to the right, and then NB to the left. Again, we can rewrite friction as normal force, so mu NA minus NB equals 0. Okay. So now the next question is, what is mu? Well, we're given phi. So to solve for mu, we'll just use the equation phi equals, mu equals tangent phi. So what's mu? If phi is 15, what's the answer? Correct, Eman and Matthew, Anulon and Santones. .27. Okay? And then just store that in your calculator for future use. Okay? So therefore, if mu is 0.27, I can solve for NA and NB. But the only thing I want to know is NB. So please solve what's NB. Correct. It's positive 22.5. Correct. Kurt and Rafaela de la Cruz and Kurt. 22.5. Okay. And then we also need FB. And FB is just mu NB. So what's FB? Correct. Correct, Pamela and Rafael. Mayo. Six point zero three. Yeah, 6.03. Okay, now I have these two. The next step is to use moment. So summation of moment at A equals 0. Let's start with 18. Rotate about A, that's clockwise, so positive 18. How do we get this perpendicular distance? Right? Well, we've noticed that perpendicular distance forms the base of a right triangle. Yes. And then to get that, we have an angle and the hypotenuse. So we can use cosine to get the base. Okay? 18. So if you write this out, cosine 60 equals adjacent. Let's call that x over hypotenuse 2.4. So x is just 2.4 cosine 60. Okay? Do the same thing here. 72 clockwise. Positive 72. And then same thing. This forms the base of a right triangle. So that's just hypotenuse, which is x, cosine theta. And then FB, rotate counterclockwise, so negative FB. Now, what are we looking for? We're looking for the base of this large right triangle. That is the perpendicular distance to A. So that's just, again, hypotenuse, which is now 6 cosine 60. And then lastly, NB, rotate, that's counterclockwise, negative NB. Now we want to get this height as its perpendicular distance, which is also the height of the large right triangle. So here using sine 60 equals opposite. Let's call this y. Okay, this is y over hypotenuse 6. So y is just 6 sine 60. There's no other force, so equate to 0. From this, please solve what's x. Correct. Pamela and Rafaela, 2 points ka na. Luis, correct. Abo. It's 3.50. And then unit meters. So this is our answer. Now take note. Usually when you have a ladder, okay, and there's a mention of weight, usually weight is at the center. So if this is 6 meters, usually weight is here at the 3-meter mark. Now that is if your ladder is homogeneous. Now usually it is unless otherwise stated. Now here in the problem, the location of your centroid is given. So meaning the ladder here is not homogeneous. That's why it's not at the 3-meter mark. Okay? If there's no mention of location of your weight, and it's not mentioned there that your ladder is not homogeneous, weight will always be at the center. So at half the span of your ladder. Okay? Okay. So that's number 4. Any questions for number 4? Please answer in the chat. Okay. How did I know that I should get NB and FB first? Okay. Because the goal here is to solve for x. X is a distance. And usually the only equation that involves distance is moment. You only can take moment about supports or about surfaces in contact. So you can either take moment at B or moment at A. However, the question is how far up the ladder can climb before slipping. So how far up, that is distance from the bottom. Okay? So this is what we're looking for, x. And then to get that, you can use moment about A. If you use moment about A, the only forces involved are 18, 72, FB, and NB. Because NA and FA passes through A, they cancel out, or you can ignore them. I don't know FB and NB, that's why those are the first things I need to solve for. Okay, any other questions? Great. If you don't have any questions, let's move on to number 5. Okay, 5. A plank 10 feet long is placed in a horizontal position with its ends resting on 2 inclined planes as shown in the figure. The angle of friction is 20 degrees. Determine how close the P can be placed to each end before slipping and bends. Okay, P, 20 degrees. So slipping and bends. What does that mean? Again, that means before motion. So that means our system is still in equilibrium. So equilibrium equations apply. So let's start with A. Because the question is how close to each end. So how close to the left end and how close to the right end. Let's start with A. How close from the left end. So I'm gonna change it. This is my P. Okay. And then this is what we're looking for. How close from the left support. Okay. Next, draw your reactions. Okay. So there's a reaction here. One that's perpendicular, and that's your normal force. And next is your friction. Now, if your force P is over here, the tendency of, or the motion of your plank would be for this end to roll down and then for this end to roll up. So the final position of your plank would be something like this, right? And again, friction opposes all those motions. So this is downward. Therefore, friction should be upward here. This is your F. Same thing here. N is always perpendicular. Okay, so this is your NB. Again, the tendency of this is to go upward if your force is here. So friction is downward. Now, there's 4 unknowns. Okay, from this, you already know there's 4 unknowns. There's only 3 equilibrium equations. So I need to do something else. So what? Well, you've noticed we're given theta, phi. And what is phi again? Phi is the angle of your resultant from your normal force. And so if I draw the resultant here, Let's call this RA. This is your phi. Okay, same thing here. Again, RA is a resultant of friction and normal force, always between the two. Okay, same thing here. This is your RB, and then this is your phi. Then now we only have three unknowns, right? P, RA, and RB. So you can solve this using equilibrium equation, summation of moment, Fx and Fy. Okay, so if you want to practice, you can do that. Now I'll show you a different approach. Since we have only three forces, okay, I can do a different method, specifically a geometrical method involving triangles. So how do we do that? So all you're gonna do is you're gonna create a right triangle out of these forces. So you can start with any. The order doesn't matter. Okay, you can start with RAP or RB. Let's try starting with RB. So just follow the direction. RB is somewhere like this, right? Next, RA is upward. And then the only thing that's important is to make sure your drawing follows orientation and it closes. Okay, so meaning if this is your RB, RA is this way, and then P is downward. Yeah. So you have a triangle, and then equations for triangle will apply. The next step now is to get your angles. So let's start with RB. This is what we want, and that is just angle from the vertical, right? It's this. How do I get that? Okay, so to get that, then you're gonna remember the relationship between your angles, your normal, and the incline. Okay, so if this is 30, right, remember, if I draw a vertical line here, this is also 30, right? And this phi is equal to 20, right? So 30 plus 20, that's 50. And if I do it this way, right? If this is 50, this is also 50, because they are alternating inferior angles. Okay, let's again, if you have an incline, let's say this is 10, this is your normal. If you draw a vertical line, this is also 10. Okay, so this is also 30. This phi is 20. So this entire thing is 50. And then alternating interior angles, this is also 50. Right? So therefore, this is 50. Next, let's go with RA. We're always going to base it from either a horizontal line or vertical line, okay? Your P is the vertical line. So next step is to solve for this. So this is what we want. Okay? Again, the angle between normal and a vertical line is the same as your slope. So therefore, this entire thing is 45. Okay? But again, phi is 20. So to get this, that's just 45 minus 20. So this is 25. Okay? 25. And then to get the remaining angle, that's just 180 minus 20 minus 50. And that is 105. Okay? And then from this, you can create the equations relating RAP and RB. So let's begin. Sine law. So side over sine theta equals side over sine theta. So let's say RB over sine 25 equals P over sine 105. And that's also equal to RA over sine 50. Okay, so this is where your first equation will come from. Next, remember again, we're looking for x. Whenever we're looking for dimension or distance, that means most likely we're going to use moment. Okay? And then to get x, I'm going to use moment about a. Okay, so summation of moment at a equals 0. So let's start with b. That's clockwise, so positive b. Perpendicular distance is your x. And that's what we're looking for. What else do we have? We're going to use RB. Okay? And then here, RB, perpendicular distance of RB from A is this length. Again, I don't want to do that. So we're going to use Varanon's theorem, which is using the components. So these are the components. Let me just choose a different color. Again, this is RB. Components are these. The horizontal component of RB passes through A, so I can ignore that. So now what I need is the vertical component. So vertical component, rotate about A, that's counterclockwise, so negative RB. Now what's the vertical component? So I either need an angle from the horizontal or vertical. Okay, so if I isolate this for us to get a clearer look, okay, this is RB. Okay, then as you can see here, this angle is 50. So you can either use RB cosine 50, because that's this component, get the vertical component, or if you want, again, what we're used to is getting the angle from the horizontal. And to get that, that's just 90 minus 50, so this is 40. So therefore, the vertical component is sine 40. Okay, so sine 40. I'm going to use that. Okay, and then perpendicular distance is this length, and that's equal to 10. There's no other force involved, so equate that to 0. Okay, and then we have two unknowns here, but I can use this equality to solve for x. Okay, so we're writing this RB. Okay, again, focusing here, sine 105 equals b sine 25. So consider this as your equation 1. This is your equation 2. Okay. You can solve for x. Please solve. What's x? Good, it's 2.8. Correct, Colin. 2 points ka na. So Marilyn and Ken. Los is the losers. And it's 2.81. Unit is feet. Okay. And then next, part B. Almost the same. Oh. Okay, let me copy that again. Okay. Yeah. And then this is what we need. Let's call that x. Okay, so now the difference is the following. So n is still the same, always perpendicular. Okay, but now this force will cause this end to slide down, and then this end will slide up. This will be the final position of your beam. And again, friction opposes that. So this is downward, so friction is upward. Same thing here. This normal force, always perpendicular. Okay, so your N. The tendency of this is to go up, so friction is to go down. And then to reduce the unknown, we're gonna use the resultant. Again, resultant is angle from N. So let's call this RB. And this is your N. And then this is your RA. This is phi. Right. Again, we're gonna use your triangles. Once again, we can start anywhere. Let's try starting with RB. Okay, so this is your RB. Next, RA. And then don't forget, closing your triangle, P is downward. We'll just make this bigger. So this is RB, RA, and then P. And like what we did earlier, let's figure out our angles. So this is RB, what I need is this, right? Or this. Or rather this. They're the same thing. Because they're alternating interior angles, okay? Again, this total angle from the vertical to your normal is the same as your incline. So this is 30. Okay? If this whole thing is 30, right? And then phi is 20. So therefore, what's remaining is 10. So this is 10. Okay, next here. So this is what I'm looking for now. Okay? And again, normal to vertical has the same angle as your incline. So this is 45. Therefore, the entire thing is phi plus 45. So that's 20 plus 45, that's 65. Okay? And then 180 minus 65 minus 10, this is 105. Okay, and again, using sine law, okay. So RA over opposite angle, sine 10 equals phi. This is the opposite angle, sine 105 equals RB, sine 65. Next, again, this is what I'm looking for. So to get that, I'll take moment about. Just again, summation of moment about B equals 0. Rotate P, that's counterclockwise, negative Px. And then RA, and I don't want to compute the perpendicular distance. So instead, we're using Varanon's theorem. This is your vertical component and horizontal. Horizontal passes through B, so ignoring that, so what I need is a vertical component. Rotate about B, that's clockwise, so positive RA. And then, how to get the vertical component? Again, I need either the perpendicular or horizontal angle. Okay. So if again I isolate that, this is my RA. Okay? And then this is 55, right? 20 plus 65. 20 plus 45, this is 65. So to get this, that's just 90 minus 65, which is 25, right? Okay, so therefore, this is, to get the vertical component, that's just sine 25. Okay, and then perpendicular distance is 10. And then once again, to get another equation relating P and RA, we use this. So RA sine 105 equals P sine 10. This is your equation 1. This is your equation 2. Using both equations, you can solve for x. So please solve what's x. Correct, Zaira and Geyser, De La Cruz Ortiz. For those who are wondering how, okay. So RA is P sine 10 over sine 105, right? This equation becomes negative px plus p sine 10 over sine 105 times sine 25 times 10 equals 0. As you can see, p cancels out. You can solve for x. Okay, so that's how you get it. And again, that is 0.76 feet. Okay, so that's number 5. Any questions for number 5? Please answer in the chat. And if you have any questions, please answer in the chat, yes or none, or your question. Okay, since you don't have questions, let's move on to the last number. I'm not going to answer number 6 anymore, because it's a bit similar to number 7. So let's move on to number 7 instead. Determine the force P required to start the wedge shown in the figure. The angle of friction for all surfaces is 15 degrees. Okay, so I'm going to answer this on my own. This is a new topic, wedge. Okay, so just listen. So again, the question is, what force P should I have to move this? And obviously, this is going to move to the right. And then we're given the angle of friction, and that is 15 degrees. Okay. So first step is to draw again your free body diagrams. So again, we have perpendicular. This is your N. This will move downward. So friction will oppose that. So this is your F. Okay. And again, there's going to be a lot of unknowns. Whenever given phi, you can just rewrite N and F in terms of its resultant R. Okay, so this is your R. Let's call this RA. Okay, that's point A. And then this is your phi. Next, same thing here. Perpendicular. Okay, that's your N. This will move to the right because of this wedge. So friction will oppose that. This is your F. Once again, yeah, this is your R. Let's call this Actually, let's call this 1. Let's call this 1. So this is R1. And then let's call this point 3. So this is R3. And then again, this is P. And then you also have these two surfaces in contact. What's going to happen there? So let's just choose a different color. Mm, okay. And let's use this. And so what's going to happen here? Okay, this is your N, considering just this block, right? This is the N. And then this is going to move downward. So friction force is upward. Okay, so this is the R for this block. Okay, let's call that R2. Mhm. And then what about this? Considering this block, okay, this is your N. Yeah. Since this is going to move downward, counter that, this would move upward. So the friction there would be downward here. And then this would be your R2. Okay, now let's separate everything. Let's start. Remember, whenever we're starting with free body diagrams, we're going to start with the one that has the least amount of unknowns. This block involves an unknown P, so we're going to start here. Okay, so starting there, you have a downward weight. Let's do this here. A downward weight here. This is 200. Then you have 50 to the left. Okay, and then we have R3. We can draw R3 this way. Okay, and then again we have this R2. So let's draw that. Then next, let's include our angles. Oh, this is easy. Why? This is phi, and that's 15. Therefore, this is just 90 minus 15, which is 75. What about this R2? R2 is this angle right here. Okay, and then to get that, recall, let me just separate that. Um, yeah. So this is also phi. Okay, it's getting a bit crowded. So this is R2. This is phi, and again, phi is 15. So this is 15. Okay, and then you have your free body diagram. You can use your equilibrium equations. Okay, let's start. Summation of forces vertical equals 0. Negative R2 sine 15 minus 2000 minus plus R3 sine 75 equals 0. This is your equation number 1. Next, summation of forces horizontal equals 0. R2 cosine 15 minus R3 cosine 75 minus 50 equals 0. And this is your equation number 2. Okay, what I need is R2 because that is the unknown in this. And again, we want to know P. So 2 equations, 2 unknowns, you can solve for R2. R2 is just 115.54. Next, moving on to this wedge. So again, we have a downward force. This is your P, right? And then we have R1. Then we have this R2. Now, how do we get the angles? Okay, R1 is this angle right here, right? It's also equal to this angle. And so remember, if you draw a horizontal line and then N, this total angle from N is just the complementary of the angle of your slope. Okay? So this angle is 15. Okay. Here, it's written here. This is 15. Okay. Therefore, complementary to 15 is, wait, yeah. Okay, so since this is 15, right, this is also 15 because they're vertical angles. So this perpendicular angles, this perpendicular to this, and then normal perpendicular to the slope. Okay, again, this is 15. So this also 15, therefore this is 15. R1. And then this is R2. Angle is the same. Also 15. Wait. How do we get R1 again? Okay. Sorry. This is 15. Total angle of R1 from the horizontal. Phi is 15. So 15 plus 15, this is 30. Okay. And then R2 is just the same angle as your previous free body diagram. Okay. So you can just copy. And again, you're going to use equilibrium equations to solve finally for P. So let's start first with summation of forces horizontal. Negative R2 cosine 15 plus R1 cosine 30 equals 0. This is your equation number 1. And then summation of forces vertical equals 0. R2 sine 15 plus R1 sine 30 minus P equals 0. This is your equation 2. Then from this, you can solve for P. Solving for P, you get 94.34 kilonewton. And that's the answer. Now, to further this discussion, okay, one of the reasons why we have wedges is to make things easier or to move blocks easier. Okay, as you can see here, if you have a wedge, I only need 94.34 kilonewtons to move my block to the right. Now, what if we don't have a wedge? Okay, now this is your block. Again, it has a weight of 200. There's a horizontal force here, 50. So let's solve what force F should I need to make this move to the right. Okay, so same thing applies. We have normal force here. This is your friction, and this will be your R3. And then this is phi. Okay, solving for that, let's start with y equals 0. Negative 200 plus R3. Okay, 90 minus phi. This would be 75 since phi is 15. So R3 sine 75 equals 0. Again, equation 1. And then summation of forces x equals 0. F minus 50 minus R3 cosine 75 equals 0. This is your equation 2. Using this, you can solve for F. If you solve for F, you'll get 103.59 kilonewton, which is greater than P. So as you can see, wedges will take less amount of force than if you were just to push it directly. So that's one of the purpose of wedges. Okay. Number 7, any questions for number 7? Please answer in the chat. Okay, so the only confusing thing here is your angles. Okay, so transferring your angles into your free body diagram. So you can just practice in order to do that. Okay, next meeting, we're gonna have a group activity again. This is your first group activity, so prepare for that. On Saturday is your modular exam. I'm gonna talk more about your modular exam on Thursday. Okay, so this ends all of our lecture for module 2. Do you have any questions, concerns, clarifications? None. Once again, group activity on Thursday, modular exam on Saturday. I'm gonna talk more about the the modular exam on Thursday as well. Okay. All right. Since you don't have any more questions, you may go. Goodbye, class.
Thank you, ma'am.